All right, we have finished off with permutations. These classes are done. So today we are going to go through the notes and examples on combinations. Chapter 11.2, you see that your assessment is right there at the end of the week. So let's get going on combinations. All right, so what exactly is a combination? Well, a combination is a count of the number of ways some objects can be selected from a group where the order of selection doesn't matter. Okay, so if you remember back to permutations, permutations look like this. I'll choose them a different color. NPR. N was the size of the group. R was the number selected. And order mattered. That was from the last section. For a combination, the order doesn't matter. Now let me explain with a little bit of difference. Let's say there's a race between 4 people. There's 4 people. There's Susan. There's Jane. There's Betty. And there is some girl whose name starts with C. There's 4 people in the races. So this 4 is N. Now in the race, 2 people can come in first and second. So we can have first place and second place. Now there's 4 choices to go in first place, and then there is 3 choices to go in second place, for a total of 12 ways to come in first and second. Now it matters if Sally comes in first and whoever J is comes in second. That's a different arrangement than if J comes in first and Sally comes in second. In permutations, the order matters. Okay, so the order matters in permutations. Now, let's take a look at what is the difference for combinations. Combinations have the same thing. They have an N, a C, and an R. So again, N here would be 4. But now all we're going to do is we are going to select, let's say they have a race and the top 2 move on to the next race. It doesn't matter if you're first or second. All that matters is the top 2 move on to this next race. So all we're worried about is the top 2. If Sally comes first and Jane comes second, or Jane comes first and Sally comes second, these are the same. We don't care about the order because the top 2 move on. It doesn't matter if you're first or second. So in combinations, the order doesn't matter. So we have a slightly different formula for combinations. And if we go back up to permutations, and you remember permutations, we had this repeated element permutation where we took the total number of unique ways and we divide it by how many are repeated. Well, something similar happens here. So our NCR formula is equal to n factorial divided by n minus r factorial. Now that's the exact same thing as the permutations formula, but then we have to do an adjustment because the order of the items doesn't matter. So what we have to do is we have to divide again by our r factorial. Because our permutations is going to count too many arrangements. We have to divide it by how many things are counted. So it's just like that. So as an example, if we do our race, from our race, example from before, there's 4 contestants in the race, and we only care about the top 2, so it's 4 choose 2. The order of the choosing doesn't matter. Doesn't matter if they're first or second. So it's going to be 4 factorial over 4 minus 2 factorial times 2 factorial. So that is then going to give us 4 factorial over 2 factorial times 2 factorial. Well, let's look at that. Simplifies down to 4 times 3 times 2 times 1, all over 2 times 1 times 2 times 1. Those cancel out. That cancels out with that, and we get 6. So if you remember, if we were doing this with permutations, there was 12. And for combinations where the order doesn't matter, this is now 6. All right, in the next short video, we will be looking at example 11.2.1, the basics.